The turret hatch slams shut. Inside, 5 men breathe diesel fumes and sweat. The July sun has turned their steel coffin into an oven. Outside, somewhere in the wheat fields of Kursk, a new predator prowls the battlefield. Soviet tankers have been whispering about it for days. A cat, they call it. A big cat, the Panther. And right now, a Soviet T-34 crew strains their eyes through a narrow periscope, searching for the beast that has already destroyed 3 of their comrades. They never see the shot that ends them. The shell comes from over 1,000 meters away, punching through the T-34's armor like paper. The German gunner inside the Panther never needed a ranging shot. He saw his target clearly, calculated the distance in seconds using markings etched into his gun sight, and fired once. 1 shot, 1 kill. Welcome to a story about the eyes of the battlefield. If you're fascinated by military history, make sure to subscribe to this channel and comment below where you're watching from right now. The summer of 1943 marked a turning point on the Eastern Front. The German Wehrmacht had suffered catastrophic losses at Stalingrad the previous winter. The Red Army was on the offensive. Hitler needed something dramatic to reclaim the initiative. Operation Citadel, the assault on the Kursk salient, would be his answer, and the spearhead of this attack would be Germany's newest tank, a machine designed specifically to counter the formidable Soviet T-34, the Panzerkampfwagen 5, known simply as the Panther. The Panther's creation was itself a response to shock. When German forces first encountered the T-34 in 1941, they were stunned. Here was a Soviet tank with sloped armor that caused shells to ricochet harmlessly away. A vehicle that combined firepower, protection, and mobility in ways German engineers had never anticipated. German tanks like the Panzer III and Panzer IV suddenly seemed obsolete. Reports flooded back to Berlin describing the T-34's capabilities. Some German officers even suggested simply copying the Soviet design outright. Instead, German engineers decided to create something better. The result was a 45-ton medium tank that incorporated the lessons learned from facing the T-34. The Panther featured heavily sloped frontal armor, 85 millimeters thick at the glacis plate, angled at 55 degrees from vertical. This gave the front hull an effective thickness far greater than the raw numbers suggested. The hull shape itself was directly inspired by the T-34, a fact the Soviets would later note with bitter irony when they captured Panthers for evaluation. But the armor was only part of what made the Panther formidable. At the heart of the Panther's lethality was its main armament. The 75mm KWK 42 gun with its 70 caliber barrel length was one of the most powerful tank guns of the war. It fired armor-piercing rounds at a muzzle velocity of 1,000 meters per second, giving it devastating, penetrating power at ranges that most Allied tank crews considered safe. A Soviet or American tank sitting at 1,500 meters might as well have been parked in a firing range target bay. But a powerful gun means nothing without the ability to aim it precisely. And this is where the Panther's true genius lay. When a tank gunner peers through his sight, he sees more than just the battlefield. He sees a complex optical instrument designed to help him place his shells exactly where they need to go. In the early years of tank warfare, these sights were relatively simple affairs. Basic telescopes with crosshairs. A gunner would estimate range by guesswork or by observing the fall of a tracer round, then adjust his aim. It was an imprecise science that wasted ammunition and time. Time in tank combat meant life and death. The Germans understood this fundamental truth better than any other nation. Throughout the 1930s, German optical manufacturers like Carl Zeiss and Leitz developed increasingly sophisticated tank gun sights. By the time the Panther entered production, German optical technology had reached a level of refinement that no other country could match. The sight fitted to the Panther Ausführung D, the variant that debuted at Kursk, was designated the Turmziel-Fernrohr 12, or TZF-12. It was a binocular sight, meaning the gunner looked through two eyepieces, one for each eye. This provided a stereoscopic view that enhanced depth perception and reduced eye strain during long periods of observation. The TZF-12 offered 2.5 times magnification with a generous 28-degree field of view. For a tank gunner in 1943, this was excellent. A wider field of view meant the gunner could scan the battlefield more effectively, acquiring targets faster than his opponents. Later variants of the Panther received the improved TZF-12A, a monocular sight that allowed the gunner to switch between 2.5 times and 5 times magnification. At the higher magnification, the field of view narrowed to around 14 or 15 degrees, but the gunner could observe distant targets with remarkable clarity. But magnification and clarity were only part of the equation. The true revolution in German tank gunnery lay in the reticle pattern etched into the sight glass. German engineers had developed a system of stadiometric range finding that allowed gunners to determine the distance to a target without firing a ranging shot. The principle was elegant in its simplicity. Alongside the central aiming point, the sight contained a series of carefully calibrated markings. These markings corresponded to the apparent size of known target types at various ranges. Picture it like this. A Soviet T-34 tank has a predictable height and width. At 500 meters, it appears a certain size in the gunner's optic. At 1,000 meters, it appears smaller. At 1,500 meters, smaller still. The German range table markings were positioned so that when a target of known size filled the space between specific marks, the gunner immediately knew the range. No guesswork, no wasted shells, no revealing your position with a ranging shot that might miss. German gunners trained extensively with these systems, learning to recognize different target orientations, whether a tank was presenting its front side or an angled view, because each orientation corresponded to different apparent dimensions. The results were devastating. In the open terrain of the Eastern Front, where tank engagements often occurred at ranges exceeding 1,000 meters, German Panther crews achieved first-round hit rates that seemed almost supernatural to their enemies. A skilled Panther gunner could identify a target, determine the range, apply the proper lead for a moving vehicle, and fire an accurate shot in seconds. His Soviet counterpart, peering through a simpler optical system without stadiometric aids, would typically need to fire a ranging shot first, observe where it landed, adjust his aim, and fire again. By the time he completed this process, the Panther had often already destroyed him. The Battle of Kursk began on July 5, 1943. It would become the largest tank battle in history, with thousands of armored vehicles clashing across a front stretching hundreds of kilometers. For the Panther, it was both a debut and a disaster. The new tanks had been rushed into production without adequate testing. Mechanical problems plagued the Panther battalions before they even reached the front. Engines caught fire, transmissions failed, suspension components broke under the stress of cross-country movement. Of the roughly 200 Panthers that started Operation Citadel, only a fraction remained operational after the first few days. Yet even as Panthers broke down in alarming numbers, those that remained in action proved terrifyingly effective against Soviet armor. Soviet tankers reported engaging Panthers at ranges where their own guns were nearly useless, watching their shells bounce harmlessly off the sloped frontal armor while return fire punched through their tanks with lethal precision. The combination of powerful gun, strong frontal armor, and superb optics made the Panther a deadly opponent in a straight fight. The problem was getting the Panthers to the fight in the first place. The Red Army captured several Panthers during the Kursk battle. Some had been abandoned by their crews after mechanical breakdowns. Others had been immobilized by mines or artillery fire. Soviet intelligence officers immediately recognized the importance of these captures. Here was Germany's newest tank, the machine the Wehrmacht expected to turn the tide on the Eastern Front. Understanding its strengths and weaknesses was a matter of the highest priority. One particular Panther, chassis number 824, was captured on July 17, 1943, by forces under General Krivoshin's command near the village of Novosolovka in the Kursk region. The tank's speedometer showed it had traveled 452 kilometers before its capture, suggesting it had seen action during the offensive before being taken. This vehicle would become the subject of one of the most thorough Soviet evaluations of German armor conducted during the war. The Panther was transported to the proving grounds where Soviet engineers and testers began their examination. The evaluation would cover every aspect of the tank's design, from mobility and mechanical reliability to armor protection and fire control systems. The Soviets were not merely curious. They needed to know how to defeat this new threat, and they needed to identify any design elements worth incorporating into their own tanks. Before continuing with this incredible story, take a moment to hit that subscribe button if you're enjoying this deep dive into military history. Your support helps bring more content like this to the channel. The mobility trials began in August 1943 and continued into October. The testing conditions were carefully documented. The Panther traveled 220 kilometers during the evaluation, with 58 kilometers on asphalt highways and 162 kilometers on dirt roads. The tank was fueled with KB-70 aircraft gasoline, the Soviet equivalent of the high-octane fuel the Maybach engine required. German grease remained in the transmission, while the suspension was lubricated with standard Soviet grease. The results revealed a tank with impressive theoretical performance but troubling practical reliability. On the highway, the Panther achieved a maximum speed of 50 kilometers per hour in 7th gear. Its planetary steering mechanism allowed relatively good maneuverability, and the hydraulic servo made the controls easier to operate than many contemporary tanks. Soviet testers noted that the turning mechanism gave the Panther advantages over both the British Churchill and the German Tiger in certain circumstances. However, the mechanical reliability was poor. During the 220 kilometers of trials, the tank broke down 3 times and had to be towed back to the proving grounds. The engine, the Maybach HL 230, proved to be the least reliable component. Soviet engineers noted constant breakdowns, including torn valve pins and rapid wear on the fan drive gears. They concluded that the engine was not finished in either design or implementation, representing a step backward from the more mature engines in the Panzer III and Panzer IV. The armor evaluation confirmed what Soviet tankers had already learned through bitter combat experience. The Panther's frontal protection was formidable. The heavily sloped glacis plate, combined with the thick turret front, could defeat most Soviet anti-tank weapons at typical combat ranges. But the sides and rear told a different story. With only 40 millimeters of armor on the hull sides, the Panther was vulnerable to flanking fire from weapons as light as the 45-millimeter gun still mounted on some Soviet tanks. Soviet analysts drew a shrewd tactical conclusion from this armor distribution. The Panther, they determined, was not designed as a breakthrough tank meant to assault fortified positions. It was a tank destroyer, a defensive weapon intended to engage enemy armor at long range from advantageous positions. The thick frontal armor and powerful gun supported this role perfectly, while the weaker side armor was acceptable if the tank could keep its front toward the enemy. This assessment would influence Soviet tactics for the remainder of the war. Penetration trials against a Panther began at the Kubinka Proving Grounds on December 1, 1943. Soviet weapons of various calibers were fired at the captured tank to determine exactly what could defeat it, at what ranges, and at what angles. The results helped Soviet commanders develop realistic engagement protocols for their tank and anti-tank units. The trials confirmed that while the Panther's front was nearly impenetrable to most Soviet tank guns at combat ranges, the sides could be defeated at distances well beyond 1,000 meters by weapons like the 85mm gun that would soon be mounted on the T-34-85. But perhaps the most revealing aspect of the Soviet evaluation concerned the Panther's fire control system. When engineers examined the TZF-12 gun sight, they found themselves confronting technology that exceeded anything in Soviet inventory. The binocular optic, with its stadiometric range-finding capability, represented a significant advantage in the critical seconds before a tank engagement's first shot. The Soviet report noted the convenient position of the aiming mechanisms and the electric firing mechanism that eliminated the mechanical delay of a manual trigger. Most significantly, they described the sight as high quality, acknowledging that it contributed to the Panther's impressive accuracy and rate of fire of 6 to 8 rounds per minute. This was not faint praise from engineers who had every reason to minimize German achievements. It was a frank admission that in this critical area, German technology had outpaced Soviet design. The acknowledgement carried particular weight because Soviet tank optics had been a persistent problem throughout the war. It was not that Soviet optical glass was inferior. Quite the contrary, Soviet factories produced excellent optical equipment. The issue lay in the design and implementation of tank observation devices and gun sights. Soviet tanks consistently suffered from poor visibility, a deficiency that gave German crews crucial advantages in combat. The problem began with the commander. In a German tank like the Panther or Tiger, the commander sat in a cupola with multiple vision blocks, providing nearly 360-degree observation. He could scan the battlefield, identify threats and targets, and direct his gunner to engage. Soviet tank commanders often had far more restricted vision. In the T-34, the commander also served as the gunner in early models, forcing him to choose between looking for targets and engaging them. Even in later designs with dedicated gunners, Soviet commanders rarely had the all-around visibility their German counterparts enjoyed. German observation device superiority was not accidental. It resulted from a deliberate development program stretching back to the First World War. The commander's cupola as a standard tank feature appeared on German designs as early as 1918. Throughout the 1920s and 30s, while Germany was officially prohibited from building tanks under the Treaty of Versailles, German engineers continued developing tank components, including vision devices. By the time the Wehrmacht began open rearmament, in the mid-1930s, Germany possessed a mature body of knowledge regarding tank optics that other nations lacked. The Spanish Civil War provided German tank designers with invaluable combat experience. German tanks fighting for the nationalist forces encountered real battlefield conditions that exposed weaknesses in their observation devices. Vision slits without adequate protection proved vulnerable to small arms fire. Glass blocks could be shattered by shell fragments. These lessons were incorporated into subsequent designs, improving the survivability and effectiveness of German tank crews. By the start of the Second World War, German tanks featured observation devices significantly superior to those of their opponents. The driver's position included a protected vision device that could be closed against heavy fire. The commander's cupola offered good all-around observation with shutters to protect the vision slits when under fire. The gunner's telescopic sight provided the magnification and stadiometric aids needed for accurate long-range gunnery. Each crew position was designed to maximize the human operator's ability to sense the battlefield and react accordingly. Soviet tank design philosophy took a different approach. Soviet designers prioritized different factors, including ease of production, mechanical simplicity, and the raw characteristics of firepower, armor, and mobility. Vision devices were important, but they competed for design attention with many other requirements. The result was tanks like the early T-34 that were revolutionary in their combination of firepower, protection, and mobility, but suffered from cramped turrets and poor observation capabilities. A Soviet tank crew entering combat faced challenges their German opponents did not share. The commander might struggle to see the battlefield clearly enough to identify targets. Once a target was spotted, communicating its location to the gunner was complicated by the lack of a proper intercom system in many Soviet tanks. Early T-34s required the commander to kick the driver in the shoulders to signal turning direction. The gunner's sight, while functional, lacked the sophisticated range-finding aids that German gunners took for granted. Every engagement became a contest where Soviet crews had to overcome inherent equipment disadvantages through skill, aggression, and numerical superiority. The Soviets were well aware of these deficiencies. Reports from the front consistently mentioned the superior observation capabilities of German tanks. Soviet tank commanders noted how German crews seemed to spot them first, fire first, and hit more often at long range. The inferior visibility of Soviet tanks was often a deciding factor in victory on the battlefield. Soviet engineers worked throughout the war to improve their tanks' observation devices, but progress was slow. The demands of mass production limited how much sophistication could be built into each vehicle. This context makes the Soviet evaluation of the Panther's gun sight particularly significant. When Soviet engineers studied the TZF-12 and acknowledged its quality, they were confirming what their tankers had experienced in combat. German optical superiority was real, measurable, and deadly. The Panther's gun sight was not merely good. It was a critical component that helped transform an already formidable tank into a precision-killing machine. The sight's design reflected years of accumulated expertise. The binocular configuration reduced eye strain during long periods of observation, important when a gunner might spend hours searching for targets. The magnification level balanced the need to see distant targets clearly against the need for a wide field of view to acquire them initially. The stadiometric range-finding marks were calibrated specifically for the ballistic characteristics of the 75mm KWK-42 gun, allowing the gunner to engage targets without revealing his position through ranging shots. Later in the war, as Germany faced increasing resource shortages, the Panther's sight was simplified. The TZF-12A replaced the binocular TZF-12, offering a monocular design that used fewer optical elements. The new sight compensated by offering switchable magnification, allowing the gunner to use 2.5 times magnification for target acquisition and 5 times magnification for precise aiming. However, Soviet and British evaluations noted that at the higher magnification, the sight markings became difficult to see, and a hard rubber eyepiece pad made it difficult for gunners to position their eye correctly. These compromises reflected the reality of German industry under Allied bombing. The precision manufacturing required for high-quality tank optics became increasingly difficult to sustain. German tanks produced late in the war often featured simplified sights, reduced vision device quality, and shortcuts in optical system manufacture. The steady degradation of German tank optics over the war's final years helped narrow the gap that had given German crews such decisive advantages earlier. The British also had the opportunity to evaluate the Panther's optical system. A Panther captured by Soviet forces was shipped to Britain for testing at the Fighting Vehicles Proving Establishment at Chertsey. British engineers removed the TZF-12 sight and subjected it to analysis at the experimental wing of the AFV school. Their findings confirmed the Soviet assessment. The sight offered good magnification options and easy switching between magnification levels, but also exhibited some ergonomic problems at high magnification. What the British evaluation underscored was that while the German sight was cleverly designed, it was not infallible. The two magnification settings each had trade-offs. At 2.5 times magnification, The gunner had a wide 30-degree field of view, but limited ability to distinguish distant targets clearly. At 5 times magnification, he could see distant targets well, but risked losing situational awareness due to the narrower field of view. Managing these trade-offs required training and experience. German tank crews received extensive training in the use of their gun sights. Gunnery instruction included practice with the stadiometric range-finding system until gunners could quickly and accurately estimate range to various target types. The famous Tiger Fibel, a training manual for Tiger tank crews, included detailed illustrations showing how to use the sight markings for different target orientations. Similar training materials existed for Panther crews. This investment in human capability multiplied the effectiveness of the technological advantage provided by superior optics. Soviet crews, by contrast, often entered combat with minimal training. The desperate manpower situation on the Eastern Front, combined with the enormous losses suffered by Soviet tank forces, meant that replacement crews frequently went into battle with only basic instruction. Many Soviet tankers learned their trade in combat, those who survived long enough to learn. This training disparity compounded the technological gap in tank optics. A German gunner with months of practice using sophisticated sights faced Soviet opponents who might be using their equipment for the first time in actual combat. The consequences played out across countless engagements on the Eastern Front. German tanks, particularly Tigers and Panthers, with their excellent optics and powerful guns, achieved kill ratios far exceeding 1-to-1 against Soviet armor. On open battlefields with unobstructed views, the German cats held superiority that bordered on dominance. Their long-range guns and excellent optics allowed well-trained gunners to target and eliminate enemy tanks at distances where return fire posed minimal threat. Soviet tankers learned to avoid such confrontations whenever possible, seeking instead to close the range where their numbers and the T-34's agility could offset German optical advantages. The tactics that evolved from this dynamic shaped the character of armored warfare on the Eastern Front. Soviet tank commanders learned to use terrain aggressively, approaching German positions through forests, villages, and broken ground that limited engagement ranges. When forced into the open, they attacked en masse, accepting that many tanks would be destroyed, but hoping enough would survive to close to effective range. Night attacks and bad weather operations increased as darkness and reduced visibility negated German optical superiority. German commanders, for their part, sought to create situations that maximized their optical advantages. Defensive positions were selected to provide long fields of fire. Panthers and Tigers were employed as fire brigades, rushed to critical points where their long-range precision could devastate Soviet armored spearheads. When attacking, German armor sought to catch Soviet formations in the open, destroying them before they could reach cover or close the range. The Soviet response to German optical superiority extended beyond tactics to technology. Soviet designers worked to improve the gun sights on their tanks, incorporating better optics and, eventually, stadiometric range-finding aids of their own. The T-34-85 that entered service in 1944 featured improved optics compared to earlier T-34 variants. The heavy tanks of the IS series received even better fire control equipment. Soviet optical factories increased production of high-quality glass and precision components, gradually closing the technological gap. By 1945, the disparity in tank optics had narrowed considerably. Soviet tanks of the war's final year featured observation devices and gun sights that, while still generally inferior to the best German equipment, were adequate for effective combat. More importantly, the Soviet numerical advantage had become overwhelming. Germany could no longer produce enough tanks or train enough crews to offset Soviet material superiority through technology alone. The legacy of German tank optics development extended beyond the Second World War. When Allied intelligence officers examined captured German equipment, They recognized the sophistication of German optical systems and incorporated lessons learned into post-war tank designs. The stadiometric range-finding principle, refined by German engineers, influenced tank sight development for decades. Western tanks of the early Cold War era featured gun sights clearly descended from German designs. Soviet engineers likewise applied lessons from their studies of captured German equipment. The examination of Panthers and Tigers at Kubinka and other testing facilities contributed to the development of improved Soviet tank designs in the post-war period. The T-54, which would become the most widely produced tank in history, incorporated features influenced by wartime analysis of German armor, including improved optics compared to wartime Soviet tanks. Take a moment to like this video if you're finding it interesting. Your engagement helps the algorithm share this content with other history enthusiasts. The story of the Panther's gun sight is ultimately a story about the human element in mechanized warfare. Tanks are not autonomous killing machines. They are crewed by men who must see the battlefield, identify threats, aim their weapons, and make split-second decisions under the stress of combat. Technology that enhances human perception and reduces human error translates directly into battlefield effectiveness. The German investment in tank optics recognized this reality and produced equipment that gave German crews a meaningful advantage. That advantage, however, could not compensate for strategic and material deficiencies. Germany entered the war with a tank force far smaller than those of its principal opponents. German industry, despite impressive achievements, could never match the combined production capacity of the Soviet Union, the United States, and the British Empire. German optics were superb, but superb optics installed in tanks that broke down before reaching the battle or in tanks destroyed by overwhelming numbers contributed nothing to the outcome. The Panther itself embodied this contradiction. Its gun sight was genuinely excellent, a precision instrument that helped skilled gunners achieve remarkable accuracy, but the tank it was installed in suffered from mechanical unreliability so severe that Panthers often failed before entering combat. The sophisticated optical systems did nothing for tanks sitting immobilized with broken transmissions or burning after engine fires. German engineering excellence in one area could not overcome German engineering failures in others. The Soviet evaluation of the Panther, conducted in the months following Kursk, captured both dimensions of this reality. Soviet engineers acknowledged the quality of the gun sight and the tank's overall design sophistication. But they also documented the mechanical failures, the insufficient crew training evident in the captured vehicle's condition, and the tactical limitations imposed by the armor distribution. The Panther was a formidable opponent, but it was a flawed one. Perhaps the most telling conclusion in the Soviet report was the tactical assessment. The Soviets recognized that the Panther was designed as a tank destroyer rather than a breakthrough tank. Its capabilities were optimized for engaging other tanks at long range, not for the combined arms operations that characterized decisive mechanized warfare. This specialization made the Panther deadly in certain situations but limited its overall utility. The Soviet IS-122, by contrast, was designed for flexibility, able to engage enemy tanks but also to support infantry and reduce fortifications. The war continued for nearly 2 more years after Kursk. The Panther remained in production and service throughout, becoming the backbone of German armored formations as the older Panzer IVs wore out. Mechanical improvements addressed some of the early reliability problems, though the Panther never became as dependable as its designers intended. The gun sight continued to provide German crews with an advantage in tank-on-tank engagements, but that advantage mattered less and less as Soviet numerical superiority grew overwhelming. By the time Soviet forces reached Berlin in April 1945, the Panther battalions that had terrified Soviet tankers at Kursk were shadows of their former strength. Fuel shortages left tanks immobilized. trained crews had been killed and replaced with barely trained replacements. The sophisticated gun sights were useless without ammunition for the guns they served. The technological sophistication that had seemed so decisive in the summer of 1943 could not compensate for the strategic reality of Germany's position. The Panther tanks captured by Soviet forces were studied, analyzed, and eventually relegated to museums and proving grounds. The gun sights that had given German crews such deadly precision were examined, understood, and their lessons incorporated into future designs. Soviet engineers who had acknowledged the quality of the TZF-12 applied what they learned to improve their own equipment. The Soviet acknowledgement that the Panther's gun sight was excellent technology should not be misunderstood. It was not an admission of overall inferiority. It was the assessment of practical engineers who understood that learning from an enemy's strengths was essential to defeating him. The Soviets won the war on the Eastern Front, not by matching German technology point for point, but by developing approaches that offset German advantages and leveraged Soviet strengths. Mass production was one such approach. Soviet factories produced T-34s in numbers that German industry could never match. If one Soviet tank crew needed 2 or 3 attempts to range on a target, while a German gunner hit with his first shot, the Soviets could afford those extra shots because they had more tanks and more ammunition. Quantity has a quality of its own, as the Soviet approach demonstrated repeatedly. Tactical adaptation was another. Soviet commanders learned to avoid situations that favored German optical superiority. Close-range engagements, night operations, fighting in built-up areas and forests. All these conditions reduced the advantage provided by sophisticated gun sights. Soviet doctrine evolved to emphasize such conditions whenever possible, accepting the costs of this approach to deny Germany the benefits of its technological edge. Finally, Soviet military leadership proved more effective at the strategic level than their German counterparts. Soviet generals might lose more tanks in individual engagements, but they won campaigns. German optical superiority meant little when German armored formations were encircled and destroyed, or when German factories producing those sophisticated sights were devastated by bombing, or when German tank crews ran out of fuel kilometers from their objectives. The gun sight mounted in the Panther tank was indeed a work of engineering genius. Soviet testers recognized this, documented it, and gave credit where it was due. The TZF-12 and TZF-12A represented the culmination of German optical development for tank applications, instruments that gave their users a genuine advantage in the deadly game of armored combat. Every element of the design, from the magnification options to the stadiometric range-finding marks to the quality of the optical glass, reflected decades of accumulated expertise. But genius in component design does not guarantee victory in war. The Panther's excellent gun sight was part of a tank that suffered crippling mechanical problems. It served crews who were often inadequately trained and increasingly demoralized. It was installed in vehicles that German industry could never produce in sufficient numbers. The sight helped German gunners hit what they aimed at, but it could not provide the strategic resources or operational flexibility that ultimate victory required. When Soviet engineers acknowledged the quality of the Panther's gun sight, they demonstrated a professional respect for excellent engineering regardless of its origin. They took what they learned and applied it to making their own tanks better. And then they continued grinding forward, tank by tank, kilometer by kilometer, until their banners flew over the Reichstag and the Panther had become a relic of a defeated regime. The story of the Panther's gun sight is a reminder that military technology cannot be evaluated in isolation. A superb weapon component means nothing without the industrial base to produce it, the logistical system to supply it, the training infrastructure to create skilled operators, and the strategic context to employ it effectively. Germany had the engineering talent to create excellent tank optics. It lacked the other elements necessary to translate that excellence into victory. Thank you for watching this deep dive into one of the most fascinating aspects of Second World War armored warfare. If you found this exploration of the Panther's gun sight and Soviet evaluation of German tank technology interesting, please subscribe to the channel and hit the notification bell so you won't miss future videos. Share your thoughts in the comments below. Where are you watching from today? What aspect of Second World War tank technology would you like to see covered next? Your engagement helps shape future content and ensures more stories like this one reach the audience they deserve. Until next time, keep exploring history.